Yeah, good day to you. Or you are welcome to Blainer Serial College class. And these particular questions are from homogeneous equation under elementary differential equation. The first question I will have here is if f of x comma y is equals to x raised power 4 minus x cubed y, what is the degree of homogeneous? So what is the degree of homogeneous? So that's what we are solving here. And a function f of x comma y is said to be of degree n, is said to be homogeneous of degree n if f of x comma y, if f of lambda x comma lambda y is equals to lambda raised power n f of x comma y. So now a function f of x comma y is said to be homogeneous of degree n if f of lambda x comma lambda y is equals to lambda raised power n f of x comma y. So now this n that we have is the degree. So now for a function to be homogeneous, wherever we see x, we change it to lambda x. Wherever we see y, we change it to lambda y. And if we're able to factor lambda out such that we still obtain the function back again, that is the function given. So this f of x comma y is representing whatever function that we are given. So if you're able to obtain that one back again, then whatever we have as the power of the lambda is called the degree. And say it is homogeneous. So now the first question I will have there is, here we have f of x comma y is equals to x raised power 4 minus x cubed y. So now we need to evaluate this f of lambda x comma lambda y. So we substitute wherever we see x, we change it to lambda x. So this one will become lambda x raised power 4 minus, so here we have x here, that will be lambda x raised power of 3. And wherever we see y, we change it to lambda y. So this one will be lambda y raised power of 1. Because the power of that y, we have a single y. So that will be y raised power 1. So now don't forget, the function given is f of x comma y equals to x raised power 4 minus x cubed y. So now, wherever we see x, we change it to lambda x. Wherever we see y, we change it to lambda y. So now from here, we have f of lambda x comma lambda y is equals to, this one give us lambda raised power 4 x raised power 4 minus, this one give us lambda raised power 3 x raised power 3, and this one give us lambda y. So now f of lambda x comma y comma lambda y is equals to, here we have lambda raised power 4 x raised power 4 minus lambda raised power 3 times lambda, that will give us lambda raised power 4. Here we have s cubed y. And again, something is common here and here, which is lambda raised power 4. So this implies that f of lambda x comma lambda y is equals to, lambda raised power 4 is common here, we factor it out. Here we have x raised power 4 left minus, this one gives us s cubed y. So now if you take a look at it, let's compare what we have here with the condition that we have above there. If f of lambda x is equal to this, so this is the function given, which is f of x comma y. So if you take a look at it very well, this is the function given, f of x comma y, that is x raised power 4 minus x cubed y. So now here we were able to factor lambda out, and the power of that lambda is what? Is 4. So you see it is homogeneous. It is homogeneous of degree 4. It is homogeneous of degree 4. That is the power of the lambda. So it is homogeneous of degree 4 because at the end of the day, we're able to factor lambda out totally because lambda was actually common to what we have here and the other one. So, and we're able to obtain the function back again, which is f of x comma y. And we're able to factor lambda out completely. Now, going to the second question. The function f of x comma y equals to exponential y over lambda y over x plus tan y over x. So determine if the function is homogeneous and of what degree. So here we have the function as exponential y over x plus tan y over x. So the question says, is it homogeneous? If it is homogeneous, then it is of what degree? So now going to the second question, f of x comma y equals to exponential y over x plus tan y over x. So that is the function given. So from here, for this function to be homogeneous, we need to write f of lambda x comma lambda y, that's lambda raised power n. Then we have f of x comma y. So wherever we see x, we change it to lambda x. Wherever we see y, we change it to lambda y. So therefore, f of lambda x comma lambda y is equals to exponential. Here we have y, that will be lambda y over lambda x. Plus here we have tan y over x, that will be tan So that will be lambda y over lambda x. So here we're going to have f of lambda x comma lambda y is equals to, so here lambda will cancel lambda, so this lambda 2 will cancel the other lambda. We have exponential y over x plus tan y over x. So now when you take a look at what we have here, we have lambda a, we have lambda a, we have lambda a, we have lambda a. So this and this will cancel each other, then this one will cancel this one too. So we have exponential y over x plus tan y over x. The question here is it homogeneous? And if it is homogeneous, it is of what degree? So now, do you know that you can write this as what? So you can write it as f of lambda x comma lambda y equals to lambda raised to the power of 0 exponential y over x plus tan y over x. So now the reason why we can write this one as this was because that we're able to obtain the function back again. Because everything that we have here, so everything that we have there is that's the f of x comma y given. That's the function given. So this was the function given initially from the question. So exponential y over x plus tan open bracket y over x is the function given directly from the question. So if you're able to obtain the function back again, then you can take the value of lambda to be what? To be raised to the power of 0. N raised to the power of 0 is 1. So what we have here and here, they are still the same thing. So now this one is homogeneous and it is of degree 0. It is homogeneous of degree 0. So it is homogeneous. So homogeneous of, so we have homogeneous of degree 0. So it is homogeneous of degree 0 because we're able to obtain the function back again. And the third question that we have here is determine whether 4y dx plus x dy equals to 0 is homogeneous. So now to determine that, so just like the way we solve examples as 1 and 2, that's the same way we solve this particular one too. So the function given here we have 4y. So the third question here we have 4y dx plus here we have x dy then equals to 0. So anywhere we see x here, we have f of lambda x comma lambda y. So that's equals to 4 lambda y dx plus this one will be lambda x dy. So now, anywhere we see x, we change it to lambda x. Wherever we see y, we change it to lambda y. And what we have here is 4y dx plus x dy. So we will not change the value of this x to d lambda x. No, it's not like that. It will not be d lambda x. So dx will remain as dx and this dy will remain as dy. So now, from what we have there, you can see that lambda is common here. So we factor that lambda out in brackets. Here we have 4y dx plus x dy. And the question is it homogeneous? If it is homogeneous, then it is of what degree? So we can see that the function here is homogeneous of degree 1. So it is homogeneous. So that's homogeneous of degree 1. So the degree there is 1. So it is homogeneous of degree 1. So that's what we have here. So, so that is all for the questions 1, 2, and 3. Kindly like this video, share and comment.